Hey class, this is Mr. Roberts at Shasta High School. We're going to look at question 82 from chapter 9. The instructions say solve the inequalities below, there are two of them, and graph your solutions on a number line. So in this first case, right, for A, we have the absolute value of something is within, it's less than 36. So two things I note when I look at this. First of all, my boundaries are open circles, right? So I am not including the endpoints because this is strictly less than, right? It's not, I don't see less than or equal to, I just see strictly less than. And I also see that it's contained within, right? It's less than this. So these b values, right, this or whatever these values in here have to be inside of this region. The absolute value is less than, it's inside of. Um, Now thinking about that, right, I can go ahead and think about my two boundary for points a bit further. On the low end, I know that that this thing b minus 4 has to be more than negative 36. Now, why did I do that? Well, we're talking about this point, right? And you can see that the values that work are above that point. They're more than this point. And this is the case if you think about the looking inside. If this was an equality, if this was equals 36, the two values are this thing inside could be either negative 36 or it could be equal to 36. This is the case where we're looking at the negative values. So what I'm saying here is that as long as b minus 4 is more than negative 36, the b values work. And the other side, I'm saying as long as the b minus 4s are less than 36, those b values will work also. Now, I don't always have to start with a sketch like this, and you'll see this pattern happen enough that you'll probably get to where you can just look at this absolute value inequality, and you could probably write down the two boundary equations just from looking at it. So they are, based on our discussion, b minus 4 has to be more than negative 36, right? Because it's less than, it's within this 36 range, and b minus 4 has to be less than positive 36. So either b minus 4 has to be more than, going this direction, it has to be more than the negative one, or it has to be less than the positive one. Or actually, that's an and statement, and both have to be true, right? Because we're talking about the values that live in between here. So this is joined by an and. It's a less than, and it's joined by and. Now on the lower end here, if I add 4 to both sides of that, this is going to say that b has to be more than negative 32. So as long as b is greater than negative 32, it will work, provided that it doesn't get bigger than 40. So over here, when I add 4 to both sides, I get 40. So this is it, right? My two boundaries are, if I think about the number line, I'm saying that values of b work if they are more than negative 32. Oops, not negative 32. If they're more than negative 32, and if they are less than the 40. So these are all values that work inside. And I can test some values in here, and it would work in the original inequality, right? All of these values will work. Values that are over here will not work, and values over here will not work. And I think it's probably worth it to take a moment and just kind of think about those three cases. So let's think about the number, let's see, something that's, so I need a value for this first one over here. I need a value that's smaller than negative 32. So I'm going to say, I'll do negative 40. I'll do negative 40. Okay. Over here, this is a value that also shouldn't work. I'll put in positive 44. So positive 44. Now, neither one of these should satisfy this original inequality. And you can see, yeah, if I put in b is negative 40, this becomes the absolute value of negative 44. And the absolute value of negative 44 is 44, and 44 is not less than 36. So you can see the values that are outside of that range do not work, right? That's why I think that's why I use the color red, because these are no go. They're stop. They don't work. If I put 44 in here, right? So now I've got 44. 44 minus 40. I'm sorry, 44 minus 4 would be 40. Absolute value of 40 is still 40. 40 is not less than 36. So that does not work. Now, any number that I pick in this range, right, any of these values will work, um, except for the endpoints, right? The negative 32 and the 40 will not work because this is strictly less than. It's not less than or equal to. So, for example, if I pick the number 14, 14, somewhere in here is the number 14. If I put that in this inequality, this is now 14 minus 4, which is 10. Right, the absolute value of 10 is 10, and 10 is less than 36. So I hope you get the idea that, right, when we have the absolute value on the left-hand side and we say the absolute value is less than a value, I hope you see the thinking here, right? And at a certain point, I'll talk to you about some mnemonic kind of memory tricks, kind of cheater things. But right now, kind of focus on the meaning. Think about what's being said here. The absolute value of something is within 36. That means it's bounded by it. It can't get more than 36 away. You can't get more than 36 away from it because it's less than 36 units away. All right, so let's take a look at part B. Part B does not have an absolute value by itself. It doesn't. It says the absolute value of 3 plus x and then minus 9 is greater than or equal to 21. So whenever I see this, the first thing that I'm always going to do is I'm going to isolate the absolute value, get it all by itself. So I'm just going to add 9 to both sides. So this is going to become the absolute value of 3 plus x is more than or equal to the number 30. So this is kind of the opposite of part A in a couple ways, right? First of all, one thing that's noticeably different is we now have solid boundary points, meaning that the endpoints that bound the solution region will be included. But the other thing is that it's not within, it's not contained by 30, it's more than 30, right? It's this way and it's this way. It's greater than 30. So these are the directions of my solutions here. It's going off to the right and it's going off to the right. It's not the stuff within, right? In fact, these values right here will not be solutions. Okay, so let's see how we can approach this. Pretty simple. Over on the lower end, right, it has to be less than this boundary. It has to be, you can see it has to be smaller than, right? So one of the things I'll say is that 3 plus x has to be less than or equal to the smaller end. That's the negative 30 side, right? And on the other side of that, we're going to say that the 3 plus x has to be more than or equal to 30, right? It's going off to the more than side. It's getting larger than that. This, if you'll notice, right, the way that this is, it's going off to the right or off to the left. It's more than, it's further away. It's like go away, it's more. That cannot be an and statement, right? Only one of these can be true. So either this is true or this is true. So when I see this greater than, I'm thinking it's going to be an or statement because it's further away. It's off, shooting off to the right or shooting off to the left. It's not less than. It's not coming inside. All right. So if I add, well, let's do this one. If I take away 3 from both sides, it's going to be x is less than or equal to taking away 3, negative 33. So x has to be smaller than, or it could equal negative 33. And on the opposite end of that, x's are those values that have to be greater than or equal to, and I'm still taking away 3 from this, negative, or positive rather, 27. So as long as x values are more than 27 or equal to 27, or on the low end they're less than negative 33 or equal to 33, we have a solution. So that's our answer, right? And if I was to graph this on a number line, we already see this sketch up there. So this boundary is included, right? And this boundary is negative 33. This boundary is included. This boundary is positive 27. And any value that is larger than 27 will work. So those all work. And any value that's less than negative 33 rather, less than negative 33 will work. So that's the graph of the inequality, and you can see my solution. It's this two statements joined by or. Either x's are less than or equal to negative 33, or they're greater than or equal to 27.